So our next section is going to be about parabolas. So when we talk about conic sections, we've already looked at circles. And the next one that we've had a lot of experience with is parabolas. Now, a lot of times when we look at a parabola, we think y equals x squared. And it's always a quadratic. So y equals x squared plus 2x minus 1. Any of those would be considered parabolas. When we get to this point, though, our parabolas, we're going to set them up just a little bit different. So this is what a parabola looks like. We're used to that U shape. And we know that if the x squared term is negative, then it flips over and it's a hill shape. So it opens down instead of up. So we're used to that information. We're going to add a little bit of information. You probably haven't looked at a focus or a directrix yet. So when we look at the focus, it's located inside the parabola. And the directrix is located an equal distance on the other side. And the directrix is, in this case, a horizontal line. If our parabola opens up to the side, it'll be a vertical line. But these two are equidistant. So we're going to call this distance P, and we're going to call this distance P. And that P is important because it's going to show up in our formula, our new type of formula when we talk about parabolas in just a second. Now, the purpose of these two things, the focus and the directrix, is that no matter what point we choose on the parabola, the distance from the focus to the point on the parabola, and from that same point vertically just straight down to the directrix, they're going to be the same distance. So just like all of the points on a circle are equidistant from the center, the radius gives us what that distance is. This p-value is going to give us that distance. So if we look over here, if we look at the focus and the directrix, and those are equidistant, here's another point on my parabola. And this one's not drawn perfectly, so it might not look like it's exactly to scale. But ideally, this distance from the focus to the point on the parabola, and from that point to the directrix, those would be the same distance also. And I should be able to pick any value, any point on the parabola, no matter how far away or how close it is. And these two distances should match up. Now again, this one's not exactly to scale, but that's the idea. So we have two different cases. We have what happens if it opens vertically. So if it opens up or if it opens down. That's the first one we're going to look at. That's the one that we're the most familiar with. So vertical axis. And usually we look at y equals x squared. But we're going to switch it up, and it's going to be x squared is equal to 4py. So we isolate that x squared piece, and we've added in this p-value. Now we already know what the p-value is going to represent. It's going to represent the distance from the vertex to the focus and from the vertex to the directrix. So this is going to give us a little bit more information. So instead of just drawing that curve, we'll have some more information that we can use to sketch out that parabola. So things that are important. In this case, if we just have x squared equals 4yp, the vertex is at the origin. So this is the equation if there's no shift involved. We haven't introduced a shift yet, and we will in just a second. The focus in this case, if the vertex is at the origin, the focus, it's going to have an ordered pair. So remember, if we're at the origin, the focus is directly above. So the x-coordinate is still going to be 0, and the y-coordinate is going to be p, whatever that distance is, whatever that p-value is, that's what we're looking at. So 0, p. And then our directrix, now remember, it's a line, so we're looking at the equation of this line that goes across. Now the equation of this line is going to be y equals something, because it only touches the y-axis. So it's going to be y equals, and we went up p to get to the focus. We're going to go down P to get to the directrix. Now remember, this is only the case if the vertex is at the origin. So y equals negative P would be the equation for that one. Now, let's introduce the shift. What if we have a vertex that's not at the origin? Well, we're going to change this up just a little. And it kind of looks like a circle in that we've got the H and the K is going to help us find the vertex. So in this case, we're going to have X minus H squared equals 4P times Y minus K. So this is going to be, instead of 0, 0, we're going to have the vertex at H, comma K. Just like the center of a circle. Now remember, when we go to the focus, it's going to have the same X value as the vertex. And then to find out what the Y value is, it's going to be K plus P. So we're going to have to go up P units from wherever that is. So whatever the P value is from my equation, that's what I'm going to use. And then when we talk about the directrix, it's going to be Y equals K minus P. So that'll give me all of those pieces. And we'll look at a couple of examples in just a second. So let's switch it around. What if we have a horizontal axis? What if we switch it and it opens to the right or it opens to the left? Well, instead of having x squared, we're going to have a y squared is equal to 4px. It follows the same patterns. So for this one, the vertex is still at the origin. We still have a focus and a directrix, but instead of going up and down from the vertex, we're going to go left to right from the vertex. So let's see. Let's say that this is at the origin. The focus would be here, and the directrix would be here. So the focus is going to be whatever the p-value is, comma 0, because it's going to stay on that x-axis. And the directrix, instead of being y equals, is going to be x equals negative p. We'll be going to the left p to get to that directrix line that time. Now, just like the other one, we're going to put in the h and k. This time, just be really careful because the y coordinate comes first. So we've got y minus k squared on this side is equal to 4p x minus h on this side. Make sure you take the x part and then the y part when you're finding the vertex. So for this one, we're going to have the vertex is equal to hk again. Just make sure when you're doing the problems you do it in the right order. And then the focus and the directrix follow the same rules. But for the focus, we're going to have h plus p, comma k. And for the directrix, we'll have x is equal to h minus p to find those equations. So let's do an example. We want to be able to sketch this out. What if I have x squared is equal to 8y? Now, this would be really easy to solve for y. We could divide both sides by 8. We would have y is equal to 1/8 x squared. And we could type it in the calculator and it could help us out. But if we're going to use this format, and if I need to know the distance that the focus and the directrix are away from the vertex, we really need to set it up using this x squared equals 4py. So I don't see a p-value here. This is 4p. So we need to split that up into pieces so that I know what the p-value is, so that I know where the focus and the directrix are going to be located. I notice there's not anything with the x and the y, so I can go ahead and say that my vertex is going to be at the origin. But we need to fix this equation so that it looks like. So basically what we need to do is divide this term by 4 to find out what the p is. Because we want to basically factor out a 4 regardless of what the problem is. So in this case, we've got x squared equals, if we divide 8 by 4, we get 2. So 4 times 2 times y. This is the p-value. So if we're sketching this out, and we can summarize all of our information too, but we know that our vertex is at the origin. And remember, we don't have a shift, so all I need is the p-value to find the focus. We need to go up p, so up 2. There's our focus. And we need to go down 2 to find the directrix. Now, usually, like I said, if we were to solve this, we would have y equals 1/8 x squared. That 1/8 tells me how tall and skinny or how short and squatty my parabola shape is. This basically does the same thing. So if I'm supposed to draw this so that it works out correctly, remember, no matter where my point is, this distance is supposed to be the same. So it's going to determine how spread out or how squished together it's going to be so that that stays the same. But that's the actual rule of a parabola. So we could label this, we could say, we're going to summarize all of our information. This one opens up. So it's our regular old U shape. The vertex is at the origin. The focus is at 0, 2. And the directrix is at y equals -2. And these two values that just came from the p that I got from my equation.